Welcome to Playing with Mathematics. Today I am going to discuss the particular integral pi of linear differential equation of higher order, which will be helpful to solve all the problems graduate level examination and books. Now for the first case, rule 1, to find of the differential equation f of d equals vx, that is, if the equation is of the form dq minus 3d plus 5y equal e to the power minus 2x. I will find only the pi of the differential equation. Now pi equals 1 by dq minus 3d plus 5 into e to the power minus 2x, that is, operate e to the power minus 2x with this function. Now putting x equals a, that is a, f d equals a, that is minus 2, then we can easily find pi equals 1 by minus 2 cube minus 3 into minus 2 plus 5 e to the power 2x, e to the power minus 2x. This will be result 3 e to the power minus 2x by 3. Now rule 1 is completed. Now for the rule 2, when the function vx is of the form sin x or sin ax plus b or cos ax or cos of ax plus b. For this example rule 2 example, 1 by d square minus 4 sin of 2x plus 3. We put minus a square in place of d square when this is not equal to 0. Now therefore minus a square means minus 2a square, that is equal to minus 4. So this equals 1 by minus 4 sin 2x plus 3, that is minus 1 by 8 sin 2x plus 3. This is so easy. Just put minus a square in place of d square. If the function is of the form f of d square form, if it is not the function of f of d square, that is example 2, in this case example 2, pi equals 1 by 3 dq plus 13d minus 2 cos of 2x. We put d square in place of d square, we put minus of a square, that is minus of 4, minus of 2, this is not equal to minus 2 the square, not equals to minus 2 the square, minus of a square, minus of 2a square, that is minus 4. Now this is equal to 1 by 3 into dq, d into d square, but d square into d square into d plus 13d minus 2, that is into cos of 2x, that is equals d square equal to minus 4, 1 by minus 12 minus 4 into 3 minus 12d plus 13d minus 2, that is equals d minus 2, so cos of 2x d minus 2. Now both in numerator and denominator we will multiply d plus 2 by d square minus 4 into cos of 2x, because we will put only d square, value of d square, function of d square, value of d square minus 4. Therefore this is equals 4 plus 2 by minus 4 minus 8 sin 2x, that is equals minus 4 sin 2x, that is equal to d of sin 2x. Sin 2x derivative of sin 2x, that is equal to cos of 2x plus 2 into sin 2x divided by minus 8, that is equals minus cos 2x minus 2x, sorry, minus this, that is equals 1 by 4 cos of 2x minus sin of 2x. Now rule 3, when Vx is of the form x to the power m must be positive integer, then we expand 1 by fd into this form and then operate this with x to the power m. But we expand this up to the power of d to the power m, as the power of Vx is the power of x to the power m. Now for the first example, 1 by 3, if we common from the denominator 3, which will be of the form 1 plus 2d plus d square by 3 into x square, that is equals 1 by 3 1 plus 2d plus d square by 3 whole to the power minus 1 into x, that is equals, expand this, we have 4, at least remember 4 expansion of the infinite series, binomial infinite series, 1 plus 1 minus x to the power minus 1, this is equals 1 plus x square minus plus x cube and so on. 1 plus x to the power minus 1 equals 1 plus x to the power minus 1, that is equals positive or negative, this is negative integer, this is x to the power minus m, Vx so yeah, okay. 1 plus minus, alternate plus minus, 1 minus x plus x square minus x cube plus and so on. Now 1 minus x to the power minus 2, 1 plus 2x plus 3x square 4x cube, and for the similar for the negative of this, alternate the sign, and 1 minus x to the power minus 3, 1 minus x to the power minus 3, this is equal to 1 plus 3x, 3 4 6 10, 1 plus 3x plus 6x square plus 10x cube plus and so on. Now apply this binomial series, this is equal to 1 by 3 1 minus 2d plus d square by 3, we will stop, or plus this equal to x. So operate this 1/3 x minus 2 by 3 derivative of x, that x square, okay, x square. So then we expand another term, since the power is x square. Now next term is this square, that is 4 d square by 9, 4 d square by 9. So this is 2 into 2x plus 2 and plus 4 by 9 into 2. So this is equals, you get the result this. Now for the problem number 2, 1 by problem number 2, 1 by d into 1 minus 2d plus d square into x cube. This is equals 1 by d, 1 by 1 minus d square, 1 minus d square into x cube, that is equals 1 by d into 1 minus d to the power minus 2 x cube. This is equals 1 by d, this is equals 1, this of the form is this 1 plus 2d plus 3d square plus 4dq. We expand up to neglecting the higher term of dq. Since the pi is of the form x cube, we expand only up to dq into x cube. Now we will operate again d with this function, this. So 1 by d plus 2d by d 2 plus 3d plus 4d square into x cube. So result gives integration 1 by d means integration x to the power 4 by 4, that is x to the power 4 by 4 plus 2x cube plus 9x square plus 24x. Now rule 3 is completed. Rule 4 to find the pi of the differential equation, this, which is of the form here fa equal to 0, that is pi, to find pi 1 by dq minus 3d square plus 4d plus 4 e to the power 2x. Here f of, if this is fd, f of 2, this is equals d8 minus 12 plus 4 0. So we will follow to solve this problem different method. First method 1, now we differentiate this, then put x a equal to d equal to 2. Now to differentiate this, 1 by 3d square minus 6d x into this, x into differentiation of this into e to the power 2x. Again we see that if we put x equal to 2, then this will be 0. f of f dash 2 equals 3 4 12 minus 12 that is equal to 0. So again we differentiate the denominator and again put another x. In this first case we differentiate this and putting x in the left of this, x into differentiation of this. If again f dash 2 equals 0, again we put x and differentiation of this 1 by 6d minus 6. Now this is not equals 0, e to the power 2x, so we put x d equal to, that is x square by 6 into 2, 12 minus 6, that is 6, x square e to the power 2x. This first method. Second method we put, this is the first method. Now second method, which is solved in AV book, put d plus a in place of this, 1 by d plus 2, a equals 2 d plus 2 the cube, so it is very large, d plus 2 the square plus 4, large method. Now e to the power 2x, e to the power 2x into 1, operate 1, solve this type of problem, solve in every book. Now this is the easiest method. Again we operate 1 to expand this with the rule 4. Now expand into the minus 1 binomial expanding form, operate 1, so it is very large method. This is so easier. Now rule 5, we will discuss rule 5 to pi of the differential equation when Vx is sin x or cos x by ax plus b form and f of minus a square equals 0, f of minus equals 0. Now example 1, pi of 1 by d square plus 9 sin of 3x. Now put d square in place of d square, put minus a square, a equals 3. Then minus a square means minus 9. Now minus 9 plus 9 equals 0. There are several methods to find pi. First method, same as this process. I will put x and differentiating this 2d sin of 3x. So the result is integration of sin 3x minus x by 2 integration of this sin 3x minus of cos of 2 minus of cos of 3x by 3, that is equals minus x cos of 3x by 6 minus x cos of. Now for the cos of x cos is, for the second method, which is the imaginary part of 1 by d square plus 9 e to the power 3 ix. So it is long method. And another method, third method, we have an formula sin of ax or cos of ax by d square plus a square, this is equals x by 2 integration of sin ax is of the form this, and integrating again if it is factor of 2, same as this integration of this. Now better method is 1, putting x and differentiating this function, then integrate of this. Now for the example 2, 1 by d plus 1 square into d square plus 1 third square into cos of x. Now this is equals 1 by d plus 1 third square. Here f of, put d square minus 1 in place of minus 1 square in place of d square. So this will be 0. Now we, for the first part, d square plus 2d plus 1 into d square plus 1 square into cos of x. Here we can easily put d square equals minus 1 for these cases. This is minus 1 plus 1, 1 by minus 1 plus 2d plus 1, that is 1 by 2d into d to the power 4 plus d to the power 4 plus 2 d square plus 1 to cos of x. Here f of minus a square is, this is 0. So we use the same rule for the example 1 by x. Now multiply also, you will multiply also 1 by 2 d to the d5 plus 2 dq plus d cos x. So we differentiating this for the rule, same rule this. So this is equals half, and x inside left side of this operator, out of operation, this 1 by derivative of this 5 d4 plus 6 d square plus 1 into cos x Also, if we put d square in place of d square, put minus of 1, this is also 5 plus 1 6 minus is equal to 0. F dash of d square, f dash of also f dash of minus of 1 equal to 0 in place of d square, minus of a square, minus of d square, f dash of minus d square, f dash of d square, putting d square equal to minus 1 is also 0. Now, so we differentiate again and taking x in the left side of the operator, that is x into x 1 by 20 dq plus 12d into cos x, 12d into cos x, that is equal x square by 2 d square equals minus s square 1 by 20 into d square into d square equal to minus 1 minus 20d plus 12d cos x, that is equals x square by 2 minus 8d minus 8d of cos x equals minus x square by 16 integration of cos x, integration of cos x, that is sin x. So this method is very easy. Either you will solve this by imagine real part of this form, which is so very large process. Now this is most easiest process, same as this or this. Now rule 6. Rule 6, Vx equals e to the power ax cos bx or sin ax form 1 by d fd d plus a e to the power ax d plus a, we put d plus a into cos of bx. This same rule, we follow the same rule of this cos of ax or sin of ax, this rule or rule 5 or 2 discussed earlier, rule 2 when sin of x cos x this form, just we operate d plus a in place of and e to the power ax at first and d plus a, and then the follow this rule, this or rule 2. Now rule 7 is also form Vx equals suppose 1 by fd e to the power ax into x to the power m. So again we operate e to the power x at first and write f of d plus a into x to the power n, and we will follow this rule 3 discussed earlier, rule 3 to solve this problem. In the next video I will discuss the 3 rules, rest 3 rules 8, 9 and 10 to find the particular integral. Thanks for watching. Stay healthy and stay safe.